Alright, now when we use this 1/16 of an inch standard imperial ruler to measure things, and then we record those measurements, we're recording them the size they actually are, and that's referred to full scale. Full scale means if it is an inch, we're going to draw it an inch. If it is 2 inches, we're going to draw it 2 inches. Whatever it measured on the ruler, we're going to draw that big. Full scale can also be shown by a ratio. 1 inch on the drawing equals 1 inch in the real world. And then sometimes full scale is expressed like this. 1 equals 1, or 1 inch in the drawing equals 1 inch in the real world. Okay, but this full scale, drawing things and measuring things out at full scale, is not always practical. In fact, a lot of times the things that we are drawing are way bigger than a piece of paper. And in order to get them to fit on a piece of paper, we need to shrink them down. Or things might be very small, we need to blow them up. So we need to change the scale. So here's an example. We want to design a commercial building, or an apartment building, or a skyscraper. Now obviously I don't have a piece of paper the size of this commercial building, so in order to draw it, I can't draw it at full scale. I have to reduce it. Floor plans for houses, same idea. They are big. I need to reduce the house to something small that fits on a piece of paper. This mechanical drawing here for ductwork within a commercial building, same thing. This is big ductwork, but in order to get it to fit on a piece of paper, I've got to shrink it down. This is Yale University. It's a campus map. We do this on maps too, right? On a map, we take a big area and we shrink it down at an agreed upon ratio so that it fits on the paper accurately. And then city maps, same idea. So we're not always going to measure things at this 1-to-1 scale or full scale. Sometimes we have to shrink things, we have to make a substitution. That's what we're going to talk about now, how to substitute one measurement for another when we're measuring large objects. So let me illustrate. Let's say we're going to make a substitution. We're going to say 1/4 of an inch on the piece of paper represents 1 foot out in the real world, because I want to draw something that's big and I need to shrink it down to fit on the paper. So, I've got a little quiz for you. I'd like to draw something that's 1 foot long. Now, this won't fit on my piece of paper. My paper is 8.5 by 11. So I'm going to substitute 1/4 inch for a foot. How long does my line need to be on the paper to represent that 1 foot? So if you said your line would have to be 1/4 of an inch long, you are correct, right? Because we said 1/4 of an inch equals a foot. That's an easy substitution, right? Good. How about this? What if I said I want to draw something and that object's going to be 4 feet long? Can you do the math mentally to be able to tell me how long to make this line to represent 4 feet? Well, if you thought 1 inch, you know what? You'd be correct. 1/4 inch equals a foot. So here's 1/4, 1 foot, 2/4, 2 feet, 3/4, 3 feet, 4/4, 4 feet. That's great. How about this? I'm gonna try to whack you here. How about I want to draw something 12 feet long? How long am I going to draw it if I substitute 1/4 inch on the paper will represent a foot out in the real world? 12 feet long. Can you do that math in your head? If you can, you probably figured out that we're going to draw something 3 inches long, right? In order to represent that 12 feet. Here's 4 feet, here's 8 feet, here's 12 feet. So, you could do this fairly easy just by using the regular ruler on the edge of your architect scale, right? Where it becomes a little tricky is when we start working with some wacky numbers. For example, at this ratio, what if I asked you, how long do I have to draw my line to represent something that is 27 feet 6 3/4 inches. Crickets. See, this is harder to do, right? I mean, you probably could do it. You could do it mathematically. But the question is, do you really want to? And I can already guess the answer. The answer is probably no. So what we're going to talk about is we're going to talk about how the other 10 rulers on the edge of the architect scale have been designed so that you don't have to use the regular ruler and do the math to try to figure out how to make lines the right length when we're reducing a big thing down to a little thing. Okay, so our next little bit of instruction goes over how to use the reduction scales on the architect scale.